Hello everyone. In this video we are going to discuss the problem of graph coloring. Graph coloring again is an optimization problem in which we have a number of tasks to perform, and those tasks require some resources where the resources are finite. So the task over here is to assign the resources to the tasks in such a way that all the tasks can be completed with minimum number of resources consumed. So it's an optimization problem where there is a restriction on use of resources. So in order to visualize the problem of graph coloring in a better way, let's say we have a map. So we have these regions, and now our task is to assign a color to all these regions so that they can be easily separable. Since we only have a limited number of colors available on the deck over here, so we would want to use as few colors as possible while assigning a different color to all the regions that are sharing a border. So if I assign a black color to this region, I have used one color, and we have colored one region. So now these regions that are sharing a border with this region cannot have the color black, otherwise their borders may not be very clear. So therefore we have to pick a different color to color these regions. So let's say we pick the red one and we have colored this region also. Now we have consumed two different colors, and as we said earlier, the tasks are to color all regions, and the condition or the constraint is to assign a different color to adjacent regions. So now this region cannot have a black or red color because it's neighbor with both of these regions that have already consumed those colors. So we will pick a third color, let's say this one, and we will fill this with blue color. So now we have filled three regions and we have used three different colors. This is the fourth region that we have got, and as we said, our optimization task is to use as few colors as possible. So we cannot consume the red color over here, we cannot use blue, but we can use the black color because it's not sharing with the region that has got black color, so we can assign a black color to this region. And now since this region is only sharing a border with the region colored black and the one colored blue, so we can actually use red color for this region because it's not sharing any border with the one that has red color. And the same way the last region can be colored in blue or even in red, so it's up to you whatever color you choose. We have actually resolved the problem of coloring all these regions, and the minimum number of colors that are required to color this is 3. So 3 in this case is the minimum number of colors that we require in order to resolve this problem of graph coloring. It's called the chromatic number. That is the minimum number of colors required. So this is the problem of graph coloring that is addressed in both mathematics and computer science. It's also called the problem of sequential coloring. There are many applications of graph coloring. For example, it can be used for course allocation or timetable generation, because we have limited classrooms and we want to accommodate all the classes to the limited number of classrooms in such a way that we do not have multiple classes in the same room or a single resource person having multiple classes in a single slot. It can also be used for memory allocation, where values that are having conflict may not be assigned the same location in memory. It can be used to allocate printers or any other resource to computers by having constraints that some computers may not share a common printer. Resource allocation So resource allocation for any kind of resource is basically the application of such a technique. Now if we look at this map of these regions, we can represent this as A, it may be B, it may be C, D, E, and F. So we have assigned a different label to each of these regions, and we can actually represent it in the form of a graph. So we have A is having a common border with B and C, so we can represent that with the help of these edges. Then B has common border with C and with D. D has got a common border with E, and it also has a common border with C. And then we have F that only shares a border with D. So in this way we can represent all our regions in the form of a graph, and we can apply the graph coloring mechanism on this, where we would want to assign a different color to each node from the ones that its adjacent nodes are. So that is the main intuition of graph coloring, and in the next video we are going to look at the greedy algorithm for graph coloring. Thank you.